All right, hello everyone, and welcome to a remote video that's going to hopefully give you some clarity on doing your review problems for our first online test. All right, so I'm going to go through these, try my best to go fairly slowly, and I'll post obviously the work that I do on a key, and I've already hosted or will be hosting office hours. So if you have any specific questions, whether that's pertaining to a question that we do here or something else like an exit ticket, we can go over that. All right, so let's get started. Number one, we have two functions, f of x and g of x, and we're asked to do two operations. The first one says f minus g of x. So the first thing that I like to do is to write down that it's going to be f of x minus g of x. And the most common mistakes that I see with the subtraction is that students don't end up subtracting all of the pieces of the second function. So just make sure you subtract every single term in the second function. That was one of the reasons not everyone got all of the questions right on the exit ticket for function operations. So we have x squared plus 6x plus 8 minus, and then to tell my brain I have to subtract everything in the g of x function, I'm going to put it in parentheses. All right, and you can distribute the negative if you would like. I don't do that. That's not efficient for my brain. I just subtract. So I'm going to have x squared, because x squared minus no other x squared is still x squared. 6x minus x is 5x. And 8 minus 2 is 6. So the function f minus g of x is x squared plus 5x plus 6. All right, let's go to the next one. The next one is f divided by g of x. So this one's going to be f of x over g of x. All right, so let's go ahead and write f of x in the numerator. So x squared plus 6x plus 8 divided by our g of x, which is x plus 2. Now, for this one, technically this is the function, but you should notice in the numerator, this is a quadratic trinomial, so I'm always going to be trying to factor that. And when I look to factor this, I'm looking for factors of 8 that add to 6. So factors of 8 that add to 6 are going to be 4 and 2. So all right, x plus 4 times x plus 2 all over my g of x, which is x plus 2. And you'll notice we have a common factor in the numerator and the denominator, which is going to make 1. That's going to leave us with x plus 4 as the answer. Now, especially for those honors students, even though we're not going to do an honors version of the test anymore because of online learning, but for my honors students, one of the big things that you need to make sure you remember here is because we have a function in the denominator that had a variable, we need to make sure to list values that you cannot use for x. So in this case, I'm going to write the function is x plus 4, but you cannot plug in -2 because it would make the denominator 0. So that would technically be the entire answer for f divided by g of x. All right, so that's everything for the first one. Now, number 2 is actually very similar, but you can see we're going to be doing the other operations here. We're going to be using two new functions, h of x and k of x, and we're going to be doing addition and multiplication. So let's start with the addition. So h of x plus k of x is going to be x squared plus 3. And even though with addition it doesn't really matter as much, I still like to get in the habit of putting parentheses around the second function that I write. So I'm going to be adding like terms here. And there's actually only one set of like terms, are constant figures. So we're going to have x squared plus 5x plus 4. So that's going to be h plus k of x. All right, so for the next one, multiplication, since we don't have a term here or a sign in between, we have h of x times k of x. All right, so I'm going to write down both in parentheses this time, x squared plus 3 times 5x plus 1. And I'm going to distribute. All right, so you're going to use FOIL if you'd like, since we both have binomials. So x squared times 5x is 5x cubed. X squared times 1 is x squared. All right, then we have 3 times 5x, which is 15x. And finally, 3 times 1 is 3. Now, we don't actually have any like terms, so this is going to be our final answer for h times k of x. This is a cubic polynomial with 4 terms. All right, so that's it right now for operations. Let's move to the next one. So now this next section is still from section 9.4, but it's about composition. You can see with all the parentheses going on that this is going to be a little different. And I would say, especially with the fact that we're doing this all remotely, that this is probably going to be where I see the most mistakes happen. So I'm going to try my best to give you some strategies to make sure you understand what it really means to do composition of functions. So the first thing that I'm going to show you here with number 3, which the first one is red, f of g of x. What I want you to do is just to pick the letter that comes first, and the first letter is the letter f. So I'm going to write down what f of x is, and f of x is x squared. But what I want to do next is instead of writing x squared, I'm going to put a box squared. Okay, so it's still technically an x squared, but I replace the x with a box because in that box is where I'm going to put the inside function. And the inside function is g of x. So I'm going to take g of x in parentheses and put it in that box. All right, so that's why I put x minus 1 in parentheses into the box. So technically the answer is x minus 1 squared, but I'm going to go ahead and distribute this. And I'm hoping, after we made a big deal of this with the radical functions, that you'll remember that when you expand a binomial and you're squaring it, you're going to square the first term, you're going to square the last term, and the middle term is the product of your two terms, and you double it. So that's going to be minus 2x. All right, so I would accept both answers, but this one is the one that I'm going to use for f of g of x. All right, so again, if you're having trouble with composition, then I recommend using the box idea where you write the first function that shows up, the first letter, that function, and replace the x with a box, and then substitute into that box the other function. All right, so let's try it again with the next one, h of g of x. So h of x is first, and that's the square root of x plus 2. So I'm going to rewrite it again, but I'm going to write the square root of box plus 2. All right, and in that box, I'm going to put g of x. And g of x, again, is x minus 1. You want to put it in parentheses. Now, because there's no constant or term in front of the parentheses, technically I don't need them anymore. And we can use a combination of like terms for -1 and +2 to get the square root of x plus 1. So that is going to be our answer for h of g of x. All right. Okay, so let's keep going with composition. This time it's going to be, instead of x, we're going to have numbers. So you could do this 2 ways, but I'm going to show you the most efficient way to do this for the SAT when you have to do this. The most efficient way to do this for the SAT, I already see, I forgot a parenthesis there, my bad, is to make sure you do the inside and then work your way out. All right, so what I tell myself is I actually ignore, when I have composition with numbers, is I ignore the very first function. So I really just care about g of 4 right now. So that's all I care about. So if I do g of 4, then I'm going to plug in 4 minus 1 and get 3. Okay, so g of 4 is 3. All right, but that's not the answer, because it doesn't just say what is g of 4. It says what is f of g of 4. Well, so that means I'm going to plug in that 3 into my first function, the f of x function. So I have f of 3. So that's going to be 3 squared, which is 9. So f of g of 4 ends up being 9. So it's almost like you're doing 2 evaluations to get these compositions with numbers. All right, so let's try it with the next one, g of f of 2. So again, I don't care about the first function g. I'm just going to do f of 2. And that's going to be 2 squared, which is 4. Again, that's not the answer. We still need to do g of that number. So I'm going to do g of 4, which is 4 minus 1, or 3. So g of f of 2 is 3. All right, so practice this. It can maybe take a few times for your brain to understand what you're doing, but you really just want to work from the inside out when you're doing composition with numbers. Okay, let's move on to section 9.5. So 9.5 was starting with how to find the inverse of a function. And there's 4 steps to find the inverse of a function. The first step is to replace f of x with y. So I'm going to replace f of x with y to write y equals x minus 1 cubed. The step number 2 is to switch x and y, because you probably don't remember this from middle school, but in middle school, what you did to talk about inverse functions was you would take points on a coordinate grid and switch the x and y values, and those were the inverse values for those points. So we're going to switch x and y. All right, and now we're going to solve for the new y. Right now that y is inside parentheses being raised to the 3rd power, so I need to get rid of that by taking the cube root of both sides. So I'm going to do a cube root with that little index of 3. Now I have the cube root of x equals y minus 1. So to finish the problem, to isolate y, I'm going to move the 1 over with addition to get the cube root of x plus 1. All right, now it says in the problem, after you find the inverse, which we did, to determine whether it is a function or not. Now, you're going to find out when we do a lot of these that pretty much 99% of the time it's going to be, yes, it's a function, so you have to do this last step. The only time that it's not a function is when you end up taking the square root or 4th root, any type of even index root of your problem. When you do that in your work, you have to include that plus or minus, which creates that piece of the function that is not going to allow it to be a function. So that's that parabola that's on its side. We'll get to that, I think, either as a review or another question. But ultimately, 9 times out of 10, you're going to just write that function, in this case f to the negative 1 power. That tells you that it's the inverse, is the cube root of x plus 1. All right, so just be careful with that when you're determining whether it's a function or not. And hopefully you remember from our last unit that if you were to sketch a cube root function, it's going to look like this. Okay, number 6. Number 6 says g of x equals the square root of x plus 2. We want to find the inverse, so replace g of x with y. Then we're going to switch x and y. All right, I'm going to isolate for y, and this time the 2 is not in the radical, so I'm going to move that 2 over with subtraction. And now to get rid of that square root, I'm going to need to square both sides. All right, so I'm going to square both sides and get x minus 2, all of that squared, equals y. Now you can leave it like this or expand it like we've done a lot of times recently. I'll accept both. You could also write y equals x squared minus 4x plus 4. Both are fine. One is in vertex form, one is in standard form, so it doesn't matter in terms of the quadratic. But the key thing is that it is a quadratic, so it's going to be parabola, so it is a function. So I need to use that inverse notation for my function g, and I'm going to choose to write it in standard form, x squared plus 4x. Excuse me, x squared minus 4x plus 4. All right, so that is our inverse. And again, if I want to graph that, it looks something like this. All right, so that's number 6. Let's go to number 7. Now, in number 7 and in number 8, for these questions, we were trying to determine with composition whether the functions are inverses of each other. So basically what this does is it gives you another way to see if 2 functions are inverses of each other instead of just finding the inverse of one and seeing if it matches. And this is really just a practice of composition. So the way we're going to do this is we're going to write f of g of x and g of f of x and hope that I get x at the end of these. All right, if I get x for both, then I know that they are inverses of each other. So let's start with the first one. So the first one says 6 over x plus 3 for f of x. So I'm going to write 6 over box plus 3. All right, get in the habit of using that box to help. So in the box, I'm going to put g of x in parentheses, which is 6 over x minus 2. Okay? So when I do some work in the denominator there to get a common denominator, I'm going to have 6 over x. All right, I need to make that have an x. That's going to be minus 2x over x. So that's going to be 6 minus 2x over x. And I have 6 over that plus 3. So when I divide 6 divided by 6 minus 2x over x, I'm not going to get x for these. So these are not inverses of each other. So again, we're hoping to get x for both, and we did not get it for the first one. So if you don't get it for the first one, then you do not have to do the second one. Okay, let's show you number 8. Determine by composition whether these functions are inverses of each other. So same idea. All right, so I need both of these compositions to give me x. So let's see what happens with the first one. So I'm going to write the square root of 3 times box. And in the box, I'm going to put x cubed. So that's the square root of 3x cubed. All right, and when you look at that, all right, the square root of 3x cubed is not going to be x. It's going to be x times the square root of 3x, all right, because you can pull out one of those x's. Oops, that 3 should be inside. So again, this is not just x by itself, so these are also not inverses of each other. All right. Now, that's pretty much all the material that is new that's going to be covered. I have more questions on here that I'll go over that are kind of like duplicates. So we're going to go back to operations. Let me give you a big picture view here. We're going to do some operations, do some composition, find another inverse, do another composition problem. But ultimately, we're going to get to the most important thing, which is the SAT questions coming up soon. Okay, so let's go back to operations. So for number 9, we have f of x minus g of x. So that's going to be x squared plus 4x plus 3 minus, and then put the g of x in parentheses, x plus 1. All right, so if I subtract the like terms, I get 4x minus x, which is 3x, and 3 minus 1, which is 2. So this is f minus g of x. Let's do the next one. This one is division again. So f of x over g of x. So we have x squared plus 4x plus 3 divided by x plus 1. Okay, so I'm going to go ahead and factor the numerator because it's a quadratic trinomial. So factors of 3 that add to 4 are 3 and 1. And you'll notice we have, again, a common factor between the numerator and denominator that's going to make 1. So we're left with just x plus 3. But don't forget, like we did a few problems ago, to give the excluded value of -1. You can plug in any number you want, just not that one. Okay, number 10. Number 10 is more operations. This time we start with addition. So h of x plus g of x. So we have x plus 3 plus x plus 5. So when you add like terms, you get 2x plus 8. All right, that one's finished. And then the next one is multiplication. We have h of x times g of x. So I'm going to write down x plus 3 times x plus 5. All right, hopefully you guys can do some of this stuff mentally now. X times x is x squared. You've got x times 5, which is 5x. 3 times x is 3x. So when you add that together, you get 8x. And 3 times 5 is 15. All right. Okay, let's do some composition. So this first one says g of f of x. You guys know when it's no numbers inside, I'm going to write down the first letter, that function g of x, which is x minus 1, and I'm going to use a box. So box minus 1. And inside that box, I'm going to put the inside function, which is f of x, which is x squared in parentheses. All right, so when I do that, I don't have anything in front multiplying, anything like that, so it's just going to be x squared minus 1. So that is our answer. G of f of x equals x squared minus 1. For the next one, we have f of h of x. So on this one, I'm going to write down f of x first, which is x squared, but I'm going to write down box squared. All right, and in that box, I'm going to put my inside function h of x, which is the square root of x plus 2. Make sure you put in parentheses. Now you guys learned last unit that when you square a square root, those are inverse operations, so they're going to go away. So f of h of x is just ends up being equal to x plus 2, what was inside the original radical. All right, so those are the two answers for these compositions. Now let's move to composition. I'm sorry, I skipped that. We're going to do inverse of this function. So replace f of x with y. We're going to switch x and y. All right, and then to get rid of that square that is around the y, we need to take the square root of both sides. And so this is what I was talking about earlier. Because we did the square root in our problem, we have to put plus or minus. So we're going to have plus or minus the square root of x equals y minus 1. So to finish the problem, you get y equals plus or minus the square root of x plus 1. All right, and it says determine whether this is a function, and this is like the only time, obviously if you did the fourth root or sixth root, anytime you take an even index root, which in this class you're just going to be doing square roots, you end up getting something that's not a function, right? If you were to look at the graph of this, you would have the parabola on its side. So it would be looking like this, and that fails the vertical line test. So actually the answer ends up being just y equals plus or minus the square root of x plus 1. We don't use that function notation for the inverse because it's not a function. Okay, let's do one more, and then we'll get to the SAT. All right, so determine by composition whether these functions are inverses of each other. So for this one, I'm going to do f of g of x. I hope that gives me x, and g of f of x, and hope that gives me x. So here we go. The first one is 2 times box plus 3, and the other one is 3 times box minus 2. So let's plug in our inside functions. So 3x minus 2, 2x plus 3. So we get 6x minus 4 plus 3, and 6x plus 9 minus 2. So that's going to give me 6x minus 1 and 6x plus 7. Now those are not equal to x, right? If you compare it to what I want, which is just x, they are not going to be inverses of each other. All right, so let's move to the SAT questions. So in this question, number 14, it gives us what I was hoping you guys would see in that Desmos activity that I first assigned, was when you had to match what you were looking at in the video to sketching a graph. So in this case, you have time on the x-axis and the target heart rate for John in beats per minute. And it says on which of these intervals is the target heart rate strictly increasing, then strictly decreasing. So in my mind, that's going up and then going down, only going up and going down if you're reading it from left to right. So if you look at letter A, between 0 and 30 minutes. So if you look at 0 and 30 minutes, it is increasing to start, but then from about minute 8 maybe to minute 30, so almost all of the minutes, his heart rate is actually not increasing or decreasing, it's remaining constant, so it cannot be A. If you look at B, between 40 and 60 minutes, from minute 40 to about 50 to 51 minutes, it's increasing, and then it's decreasing from about 51 minutes to, looks like 61 minutes, so that one is going to be the answer. That's strictly increasing, then strictly decreasing. But let's look at the other answer choices. Between 50 and 65 minutes, that's strictly decreasing to then strictly increasing, so they flipped it to try to confuse you. And then for 70 and 90 minutes, you've got, it starts constant, then increases, then it's constant. So that does not have strictly increasing to strictly decreasing. Okay, number 15. Number 15 I put on the review because we didn't do much with graphing with looking at this. So that's why I want to make sure that it wasn't on the test. But it says, if you look at this function, which of the following are equal to 1? So it gives you f of -4. So if I look up here at -4 on the x-axis, so 1, 2, 3, -4, the y value is +1. If I look at the same thing for f of 3/2, which is the same as 1.5, that's also going to be +1. And if I look at 3 on the x-axis, 1, 2, 3, and that y value is also +1. So they're all going to be equal to 1. So that one's going to be D, 1, 2, and 3. They're all equal to 1. Okay, number 16. Again, this was graphing, so it was a little tricky, but this is asking you to add functions to get 0. All right, so the way you want to do this is if you look at all these answer choices, like if you start at -3, so -1, -2, -3, your y value for your f of x function looks like it's -1, and your y value for the g of x function also looks like it's -1. So you'd be adding -1 plus -1, which is not 0. If you go to -2, the f of x function for that one, the y value is -2, and the y value for g of x is at +2. So that one is going to be the answer. That is 0 when you add those together. If you do the same thing for -1, you'll have the same answer as part A. They're both at -1. And at 0, the f of x value is, the function's at 2, and the g of x is way down there. Let's see, 1, 2, 3, 4, 5, 6. It looks like it's almost at -9. So when you add those together, you get like -7, so not 0. All right, let's look at 17. It says, snow fell and then stopped for some time. When the snow began to fall again, it fell at a faster rate than it had initially. Assuming that none of the snow none of the snow melted during the time indicated, which, okay, science, that's not how that works. Which of the following graphs could model the total accumulation of snow versus time? So when you read that when it fell again, it fell at a faster rate, we're talking about accumulation, that just means the slope is going to be steeper. So I'm really looking for, it to have a somewhat of an increasing line, then a constant line because it stops snowing, and then a steeper increase when it begins again. And B has all that I just mentioned, but the problem with B is that it's actually steeper to start. So that would say that it's actually snowing harder at the beginning than later. C has the initial snowfall and then it stops, but then it has accumulation going down. So that means it's melting, which we're assuming there's no melting. And D is a line, so that means it's only going to be snowing the whole time. So the only one that leaves us is A, where it increases slightly, then the accumulation levels off, so it's constant. There's no snow falling or melting. And then it increases again, but at a faster rate, steeper slope than initially. So that's why it's A. Number 18. All right, so it says, on what interval did the number of figurines decrease the fastest? So decrease is going to be a negative slope from top left to bottom right. And when it says the fastest, again, that's the steepest decrease. So I see a couple of decreases between 1 and 2, and then between 3 and 4. So I'm really looking to see between these two and these two, which one is steeper. And it looks like the one between 3 and 4 months is a steeper decrease, so that's why it is C. For between 2 and 3 months, it increased, so it did not decrease. And between 4 and 5 months, it increased as well. All right, so that is it for the review. Again, we'll have already had office hours, so you're just watching this again to refresh, or you're going to ask questions specifically about any of these questions when I host office hours. All right, if not, good luck on the test.